Problem 205, Classical Mechanics. The question is, a ball of mass m is dropped from a tall building with zero initial velocity. In addition to gravity, the ball experiences a damping force of the form minus gamma v, where v is its instantaneous velocity and gamma is a constant. Given the values of m is equal to 10 kg, gamma is equal to 10 kg per second, and g is equal to 10 meter per second square, the distance traveled in time t second is. The differential equation in the falling ball problem is m into dv by dt is equal to mg minus gamma v. We can write it as dv by dt plus gamma by m into v is equal to g. Let gamma by m is equal to p and g is equal to q. So our differential equation is of the form dv by dt plus pv is equal to q. Now let us compare this differential equation with the standard differential equation dy by dx plus py equal to q. Then the integrating factor is e raised to integral p dx. Here the integrating factor will be e raised to integral p dt, that is e raised to integral gamma by m dt, that is e raised to gamma by m into t. Once we have the integrating factor, we can find out the solution. In the present problem, the solution is v into integrating factor, that is e raised to gamma by m into t is equal to integral q into integrating factor dt plus c1, that is integral g e raised to gamma by m into t dt plus c1, and that is equal to g m by gamma e raised to gamma by m into t plus c1. Now at t is equal to 0, the velocity is equal to 0. This implies that 0 is equal to gm by gamma plus c1, or c1 is equal to minus gm by gamma. Now substitute the value of c1 in equation number 1. We have the equation 1 becomes v e raised to gamma by m into t, that is equal to g m by gamma e raised to gamma by m into t minus gm by gamma, or v, that is the velocity, is equal to gm by gamma minus gm by gamma e raised to minus gamma by m into t. This is the expression for the velocity. We can write it as v is equal to gm by gamma 1 minus e raised to minus gamma by m into t. This is the expression for velocity when a ball of mass m is dropped from a tall building with zero initial velocity. We have to find out the displacement. X is equal to integral v dt plus c2, that is gm by gamma integral 1 minus e raised to minus gamma by m into t dt plus c2, that is the distance traveled x is equal to gm by gamma, then within bracket t plus m by gamma e raised to gamma minus gamma by m into t plus c2. This is the distance traveled in time t second. Let it be equation number 2. We have to find out the constant of integration c2. At t is equal to 0, the distance traveled is 0, that is 0 is equal to gm by gamma, then 0 plus m by gamma plus c2, that is c2 is equal to minus gm square by gamma square. Now substitute the value of c2 in equation 2. Our equation 2 becomes the distance traveled in time t second x is equal to gm by gamma, then t plus m by gamma e raised to minus gamma by m into t minus gm square divided by gamma square. This is the general solution for the falling ball problem. Now it is given that the mass m is equal to 10 kg it is given that the mass m is equal to 10 kilogram, gamma is equal to 10 kilogram per second, g is equal to 10 meter per second square. Therefore, the value of x becomes, or equation 3 becomes, x is equal to 10 into 10 by 10 within bracket t plus 10 by 10 e raised to minus 10 by 10 into t minus 10 into 10 square by 10 square. Here 10 and 10 cancel. That is 10 into t plus e raised to minus t minus 10. That is the distance traveled x is equal to 10 into t plus e raised to minus t minus 1. Hence, from the given option, option B is the right option.